Welcome back. Thanks again for sending over all that amazing stuff on AI agents, articles, research, all that. We've been digging through it all. And today we're going to really dive deep into generative AI agents, going way past just the basics of language models to figure out how they're built, how we know if they're actually any good, and some pretty surprising ways they're being used, especially in companies and even cars.
It's really interesting stuff. And the range of information you've given us is great. So our goal today is to pull out the most useful parts for you. And try to cut through all the noise and make this whole fast-moving area a little clearer.
So first things first, what exactly is an AI agent? This agent's companion you sent over says it's basically an app designed to achieve specific goals.
Right.
And it does that by taking in information from its environment and then acting on it using whatever tools it has. But here's the thing. These agents aren't just following a script, right?
Right.
They're using reasoning logic, and they can even access outside info.
Yeah.
The big thing is they operate autonomously. They make their own decisions to reach their goals.
Exactly. That autonomy is what makes all the difference. That ability to go after goals on their own, that's what sets them apart.
Okay, so let's break down how these agents actually work. Our readings point to three main components. First, there's the model. Think of it like the agent's brain. The language model at the core.
Yeah.
It's the decision maker using instructions and logic to figure things out. But it's not like a one-size-fits-all brain.
Definitely not.
It can be a general model or something more specialized, like a multimodal model that understands images and audio, or even one fine-tuned for a really specific purpose.
Right. It totally depends on what the agent's job is. Like an AI helping with customer service might use a model trained specifically on customer interactions and product info.
Makes sense. Then there are tools. This is how the agent interacts with the world around it, like giving it hands to do stuff.
I like that analogy.
It lets it access external information and services. Could be extensions connecting to APIs, functions running code, or even data stores with up-to-date info. So if an agent needs to book a restaurant, the tool might be an extension that talks to the booking services API.
Yeah, exactly. Tools are what let the agent take action. They bridge the gap between thinking and actually doing things out in the world.
Yeah.
Without good tools, the agent's smarts would be stuck inside the computer.
Right, useless.
Useless, yeah.
And the last piece is the orchestration layer. This is like the behind-the-scenes manager, right?
Yeah.
It's the constant cycle of the agent taking in information, processing it, and deciding what to do next. This means managing memory, its understanding of the situation, its plans, and even how we prompt it to guide its thinking.
Yeah.
We saw some pretty interesting reasoning techniques like React, Chain of Thought, CoSteve, and Tree of Thoughts, TOTI.
What's cool here is how the orchestration layer ties the model and tools together. It's not just about a powerful language model or having good tools. It's how the agent cleverly uses those things to reach its goal. Like, React helps it go back and forth between thinking and doing.
Okay.
While CoTi helps it think through hard problems step by step. TOTI takes that even further, letting the agent explore multiple paths of reasoning before choosing one.
So it's like having options.
Yeah, like weighing the pros and cons of different approaches.
So if we get these three core things, the model, the tools, and the orchestration layer, we basically understand what makes these agents tick, what makes them smart and capable.
For sure. And as these agents get even more advanced, figuring out if they actually work well becomes crucial. So how do we evaluate them? That's a big question.
Yeah, good point. It seems more complicated than just checking the final output, like with a regular generative model.
It is.
The sources say we need to understand the agent's process. It's not just what it makes, but how it gets there.
Absolutely. It's about looking beyond the answer and seeing the whole journey. And this agent evaluation basically has three parts. The first is assessing its core abilities.
Like how well it understands and reasons, that sort of thing.
Yeah, exactly. Like, can it accurately follow instructions and think logically?
And there are tests for this, right? Like BFCL and Bench to see how well it uses tools, and Plan Bench for planning skills.
Right. Those give us an initial idea of what it can do.
But the sources also say we need evaluations for specific situations, right?
Yeah, that's super important. Those public benchmarks give us a general sense, but they might not show how well it'll do in your specific use case.
Right.
Plus, agents kind of inherit behaviors from the systems they're built on.
Oh, okay.
So existing ways of measuring those systems can be helpful too. Agent Bench is mentioned as a more well-rounded benchmark trying to assess performance across different scenarios.
I see. So it's not just one test fits all.
Yeah.
The second part of evaluation is about the trajectory, like the path it takes to reach the goal and how it uses its tools. We need to understand this to find problems and make things better.
Right, and we can actually assess these trajectories automatically. There are 6 ways to do this if we know the correct path: exact match, in-order match, any order match, precision, recall, and single tool use.
Okay.
They compare the agent's actual steps to the expected ones. So exact match means the agent has to follow the ideal path perfectly. In-order match is a bit more flexible, allowing extra steps as long as the main actions are in the right order.
Makes sense. But we need that ideal path to compare against. That's where agent autorators come in, right?
Exactly. Making those ideal paths takes a lot of work. Agent autorators are LLMs that act as judges, basically. They can evaluate a trajectory without needing a predefined perfect one.
That's pretty smart. And the third part of evaluation is looking at the final result. Did it do what it was supposed to do? And since there might not always be one right answer, we need to define what success means for each situation.
Exactly. Success for a customer support agent might be solving the issue quickly and well. For a research agent, it might be giving a thorough and accurate summary. To automate this, we can use LLMs as judges again, checking the output against those specific criteria.
Right.
But the key is, when there isn't a single correct answer, being precise about your evaluation criteria becomes really important.
So all this thorough evaluation, looking at abilities, process, and results, helps us turn these agents from cool ideas into tools we can actually rely on.
Absolutely. And it's not only automated evaluation, human evaluation is super important too.
Oh yeah, why is that?
Well, even with all the fancy automated stuff, we still need human judgment. Especially for things algorithms struggle with, like creativity, common sense, and understanding the subtle stuff.
That makes sense. Humans bring real-world context that computers often miss.
Exactly, and it's key for making those little improvements, getting insights into how to fine-tune the agent's behavior and learning. And like we said before, feedback from humans can even help us check if our automated evaluation is working right.
Right. The sources mention a few ways to get human input. Direct assessment, where experts rate the agent; comparative evaluation, where they compare it to others; and user studies, where people actually use it and give feedback.
All these approaches are useful at different stages of development.
Okay.
It's about making sure our agents are not just technically good, but also good for the people using them.
Now, what about scaling things up, moving past a single agent to using many?
That's where multi-agent systems come in. It's like assembling a team of specialized AI experts to tackle those really hard problems.
Okay, so instead of one agent doing it all, you have many, each focused on something specific, all working together, like a dream team, with each member bringing their unique skills to the table.
Exactly. And each agent might even use a different language model and have its own knowledge base.
Wow, that's pretty cool. It sounds like there are some big advantages compared to just one agent trying to handle everything. The sources mention things like higher accuracy because each agent's a specialist, better efficiency by breaking down tasks, and better handling of really complex problems.
Yeah.
And also increased scalability by just adding more specialized agents as needed.
All true.
Plus, it's more resilient because if one agent fails, others can pick up the slack. And maybe even fewer errors and biases by getting input from different perspectives.
It's a much more robust and adaptable system.
So how does this all work? What's the structure behind it?
Well, multi-agent systems rely on principles like modularity, where each agent is self-contained.
Okay.
Then there's collaboration, where they communicate and share info, and sometimes hierarchy, where some agents manage others.
So it's like a well-organized team, and
Yeah.
these agents have different roles too, right?
They do. You've got planner agents figuring out the steps,
Okay.
retriever agents finding the info, execution agents doing the actual work, and evaluator agents checking the results.
So each one has its own specialty, and how do these agents actually interact? Are there patterns to this?
There are. Our sources talk about sequential patterns, where one agent's output becomes the next one's input.
Mm-hmm.
Then there's hierarchical, with a manager agent directing others.
Right.
You also have collaborative patterns where agents share info,
Okay.
and even competitive ones where agents might compete for the best outcome, like in that overcooked AI example where agents learn to cook together in a game.
Oh, I remember reading about that. It's fascinating how these different ways of interacting can be used in businesses.
It is.
Streamlining processes and making the whole system more reliable.
Exactly.
It sounds like there's a lot going on under the hood to keep these multi-agent systems running smoothly.
Definitely. There are interaction wrappers to manage communication,
Okay.
memory management for storing and retrieving information,
Right.
cognitive functionality for reasoning and planning, tool integration to connect to external resources, and a bunch more.
So it's not just about the individual agents. It's how they all work together.
Yeah, the whole ecosystem is important.
But surely managing all these interacting agents can be a bit tricky, right?
It can be. The sources do mention challenges, like coordinating communication and reasoning across all the agents, making sure tasks are assigned efficiently, managing shared information, and the potential for higher costs and complexity.
Right, it's not a magic bullet.
No, but the potential benefits are huge, especially when it comes to information retrieval.
And that brings us to Agentic RAG. We talked about regular RAG before, where we get info from a database and feed it to a language model, but Agentic RAG seems like a major step forward.
It is. Traditional RAG can be pretty static. Agentic RAG brings in these autonomous retrieval agents that actually refine their search based on the context and their own reasoning.
Oh, so it's not just one search and done.
No, they can generate different versions of their search query, break down complex questions into smaller parts, choose the best sources, and even check if the info they find is accurate.
So it's a more dynamic way to find the right info.
Yeah, much more.
This would be incredibly useful in fields with tons of complex knowledge, like law, science, and business. For example, instead of just doing a keyword search for legal stuff, an agent could understand the nuances of a legal question and find the most relevant precedents.
That's the idea. The benefits over regular RAG are pretty big. Improved accuracy because agents can judge the reliability of sources, better context understanding because of this iterative process, and greater adaptability as agents adjust their strategies.
Right, it's not just about finding any information, it's about finding the right information.
Exactly. Like the sources say, better search, better RAG.
But even with this agentic RAG, the quality of the search itself is still important, right?
Yeah, no.
There are things we can do to improve search results for any ag system, like carefully breaking down documents into smaller, meaningful chunks. The sources mentioned Vertex AI layout parser and semantic chunking for this.
Right.
And we can add useful metadata to those chunks, fine-tune the embedding models, use specialized search tools, and even make sure the generated text is actually based on what was found.
Absolutely. And tools like Vertex AI Search and RAG Engine can help make all this easier.
Right. They handle a lot of the complexity behind the scenes. So with all these advancements, where do we see this technology actually being used? One area that stood out was the enterprise.
It's going to be huge. In fact, the sources predict 2025 as the year of the agents for businesses.
Wow. The year of the agents. That's quite a statement.
It is. And we're going to see two main types. Assistants that help users directly with specific tasks, and automation agents that work in the background monitoring and making decisions.
Okay, so one's like a personal helper and the other's more like an invisible manager.
That's a good way to put it.
What's really interesting is the idea of knowledge workers becoming managers of agents. Instead of just using software, they'll be assigning tasks to these agents, managing the flow, and keeping an eye on things.
It's a whole new way of working.
Exactly. And Google Agentspace is mentioned as a platform designed for this.
Yeah.
It uses Gemini and Google Search to overcome the limitations of old knowledge systems, giving us personalized experiences, automation, better context, and more comprehensive retrieval.
It also focuses on building trust through strong security, explainability so we can understand how agents make decisions, and governance controls. And it's designed to connect with many enterprise systems, has customization options, real-time feedback, blended RAG, and the ability to handle large workloads. Plus, that focus on security using Google Cloud with detailed IT controls is huge for businesses.
Right. Security is key. We also saw Notebook LM Enterprise, which is more for research and learning.
That's right.
It lets you upload and analyze tons of complex info and even makes AI-powered audio summaries.
It's a great tool for making sense of complicated information quickly.
And then there's Google Agentspace Enterprise.
Yes. This is going to be big.
It's like a single branded search agent for all the information in a company, giving conversational help, recommendations based on context, and access to both unstructured and structured data, even with translation and pre-built connectors.
It's really comprehensive.
The cool part is that these agents can actually take actions within company systems and manage tasks that might take a while to finish.
It's taking AI agents from just providing information to actually getting things done.
Absolutely. There's also the idea of creating custom agents for specific business functions.
Yeah. Tailored to exactly what they need.
And a central place to manage all of them.
It's about bringing order and efficiency to this whole agent landscape.
It's a lot to take in, but incredibly exciting. And one more thing that really stood out was this idea of contract adhering agents.
Ah, yes, this is a really interesting development.
It's about tackling those really complex, high-stakes tasks by setting up clear contracts between the person asking for something and the AI doing it.
Right. The idea is to be super clear about what the goal is.
Right. No room for misunderstanding.
Exactly. So the agent can later check its work against these expectations. It also allows for negotiation and clarification beforehand to avoid confusion, and it can even break a big task down into smaller subcontracts.
So it's like having a legally binding agreement with the AI.
Well, not legally binding, but you get the idea.
The sources even list out what these contracts should include. Things like a detailed description of the task, what the deliverables are, the scope of the work, how long and how much it will cost, where the info comes from, and how reporting will work.
It's all about transparency and setting clear expectations up front.
And there's a model for feedback and negotiation too, covering things like identifying where the initial request might be unclear, negotiating the cost, pointing out risks, and seeing if more input is needed.
It's a very structured and iterative process.
And then the whole thing has a life cycle. Defining the contract, negotiating it, and then executing it. The focus during execution is on quality and completeness, often allowing for multiple attempts and giving the agent the ability to check its work against those initial expectations.
It's similar to what we've seen in studies like co-scientists and systems like AlphaCode that are all about making sure results are verifiable.
Negotiation is important too, for prioritizing tasks and allocating resources, and feedback helps to spot and fix any issues early on.
It's all about communication and collaboration, even with AI.
And then there's the subcontracts, breaking down big tasks into smaller, more manageable pieces.
It's about making complex tasks less daunting and more achievable.
To see how this all works in the real world, the sources give a great example. Multi-agent systems in cars.
Ah, yes, this is where it gets really interesting.
It's a great example of how this technology can be used in a complex and safety-critical environment.
Exactly. Cars nowadays need to do a lot of things, and they don't always have good internet access.
Right.
Multi-agent systems are a really effective way to deal with this.
We saw a bunch of specialized agents for cars. A conversational navigation agent for finding places and giving directions, a conversational media search agent for finding and playing music or podcasts, a message composition agent for sending messages using voice commands, a car manual agent that uses RA to answer questions about the car, and a general knowledge agent for answering random facts.
And the key is how these agents are combined, using different patterns to handle complex requests. There's the hierarchical pattern with a central orchestrator agent that routes requests to the right specialized agent.
Okay.
Then there's the diamond pattern, where a moderation agent refines responses from other agents, maybe making them more user-friendly.
I see.
And the peer-to-peer pattern, where agents can pass a query to another agent if it's not for them.
Makes sense.
Then you have the collaborative pattern, where multiple agents work on different parts of a request, and a response mixer combines their answers.
Oh, okay.
And finally, the adaptive loop pattern, which lets a request be refined through multiple attempts.
That's a lot of different ways to use agents.
It is, and each pattern has its own strengths.
So what are the big advantages of using this multi-agent approach for AI in cars?
Well, specialization means each agent can be really good at its specific job. It's more efficient because each agent is optimized. Speed is improved because some functions can run directly in the car without needing the internet, and the whole system is more resilient because things can keep working even without a constant connection.
So it's all about making the system smarter, faster, and more reliable.
Exactly. And the best part is we have the tools to build these sophisticated AI agents. Vertex AI Agent Builder is presented as a complete platform with Vertex AI Agent Engine for easy development and a managed runtime environment. There's also Vertex AI Evil service for evaluating everything, from language models to whole agents.
Right, that's what we were talking about before.
Plus, it has access to all sorts of agent tools, like retrieval capabilities through Vertex AI Search or RH Engine, ways to get information from databases, tools to integrate with other applications, and even ways to turn existing APIs into tools.
So it's a whole suite of tools designed to make building and using agents easier.
Exactly. And of course, it gives access to those cutting-edge large language models like the Gemini family through Vertex AI Model Garden.
So it seems like the future of AI is becoming more and more about these agents. We've gone deep into what they are, how we make sure they're good, the power of them working together, the new stuff with Agentic R, and those real-world examples in business and cars.
We've covered a lot. It's clear that AI agents are a big step forward in AI.
It really makes you think. As these systems become more common in our lives and jobs, how will they change the way you approach your own work or interests?
It's an interesting question, and it leads to a final thought. As AI agents become more woven into our lives, how will we go from being users of technology to maybe becoming the ones who orchestrate these AI capabilities? And what new challenges and opportunities will that bring? It's something to think about.
Definitely. And maybe our listeners can explore those resources you sent and look deeper into the things that interested them during our conversation.
I think that would be a great next step. There's so much to learn and discover in this space, and it's only going to get more exciting from here.